Hello, this is Cordia Campbell, and today we're going to be going over databases. Database is an organized collection of structured information or data. They are used to store, retrieve, and manage data that come from various applications. Databases are key to efficient data storage and retrieval. Databases consist of five main components, namely they are hardware, software, data procedure, and database access languages. Here you see the breakdown of each one of those components. Now, we're going to get into the types of databases. There are several, or shall I say, various varieties of databases. One of the most common type is the relational database. It's been around since the 80s. It's where they take data and put into tables and columns, kind of like Excel. Some of these varieties of databases are specifically designed for use in science, finance, and other sectors. But with the advent of things like the cloud storage, they're going to have rise for new and different databases. Here we get into the different types of databases. Relational databases, which is one of the most common, and you have here examples. MySQL, SQL Server, Oracle, and some of their uses like banking systems, CRM systems, inventory systems. Um, One thing about the NoSQL databases, they are designed to be more flexible and scalable because of the high data storage. Also, the NoSQL databases, they're gaining popularity because of a lot of the different web applications. As you see, some of their common uses are social networks. Continuing with the type of databases, we have in-memory databases. They are used for faster access times. When you have to go back to something real quick, this is the kind of database you'll use as it has real-time data processing. We also have object-oriented databases. These databases, they store data in the form of objects instead of using the conventional rows and columns. They are a little less commonly used than a traditional database. Time series databases. You'll find this in use in stuff like stock market and um, application performance matrix. They use this for the financial data applications and also for the time stamping of this feature. New SQL databases. Google Spanner, CockroachDB, just to name a couple of them, designed to provide the scalability and flexibility of the NoSQL databases, but they maintain the guarantees of the traditional DBMs. So let's get into the technical composition of databases. What are they comprised of? What are they made of, right? Let's do that. Some of the technical compositions of a database include the database management system. This is software that is designed to create, manage, and interact with databases. They react with relational databases, the traditional ones, and the NoSQL databases. You also have data models. You want to take the data that you have occurred and put it into a different model to be able to represent it better. And for that, you have different models here. You have relational models, document models, key value models, and you have graphs. Me personally, I think I would use the graphs, but the other ones may work just as well. We have tables in databases. Use these tables um, to define the structure of the database. You have schemes, rows, columns. That's just like the regular relational databases or RDBMS. We have indexes used to retrieve different information, speed up data. We also have queries here. Databases use query language to interact with each other. That's a key function of the database. Transactions and asset properties. Databases um, use a sequence of operations performed by a single unit. ACID, or ACID, ensures that these operations maintain integrity. Replication and backup for data redundancy. Backups are taken periodically to ensure data integrity and recovery in case of failure, which is a must for any security application. Now that we have went over all the points of databases, their purposes, and what they can do, we're going to go into some of the challenges of databases. In today's large enterprises, database support very complex queries. They're expected to deliver almost instantly. Um, to do this, they require a lot of help to improve their performance. And to address all these challenges for some of the administrators and employees, that can be time consuming. They may not be able to do other things while they're addressing the database issues. They face issues like absorbing significant increases in data volume because it might be a spike in volume coming into your organization. They also have to ensure data security from hackers and other abusers of the system. Uh, some of the challenges include keeping up with demand. How can your database system keep up with demand of the information that it's getting? Managing and maintaining the database and the infrastructure. Putting together a database system for today may not be what you need for tomorrow. So it will require upkeep and maintenance. And also removing units on scalability that coincides with maintenance and maintaining the database and infrastructure of your network or your system. Also, we have ensuring data residency, data sovereignty, or latency requirements. These are some of the challenges that we face with databases. Let's talk about database hardening, making your system secure. How do we do that? We have a couple of recommendations. Use strong authentication. which means enforcing strong passwords, multi-factor authentication, and limiting privileged accounts. We also can limit database access to people who require that to do their job. Remove unused accounts. You may have an employee that is no longer working with you. You don't want them to have access to your database. Other hardening recommendations include encrypting your data from end to end. Um, you can use SSL or TLS encryption. And you also use this encryption for your backups. Another recommendation would be enable auditing and monitoring. So you can audit the logs of who's coming into your system and who's going out, how long they've been there, and what they've been doing. Monitor for suspicious queries. Hey, what are they looking at? We need to know this. Also, updating your database firewall for any kind of intrusion detection. To secure your database, you also want to patch and update regularly. You want to do this as often as possible so there won't be any way that somebody can come and hack you. Disable unused database features. A dormant feature would be a backdoor for some person to come in and hack your system. So to wrap this up with a summary, databases are essential to modern computing. Yes, they are. They come in various forms and different models, each one suited for different cases and uses. The choice of a database depends on specific needs of the application and the data consistency. As far as hardening databases, it's a critical aspect of securing your system. This involves controlling access, encrypting sensitive data, applying patches, and regularly monitoring activity. This will greatly reduce the risk of unauthorized access to your sensitive information. Thank you for watching. This is the references. See you on the next one.